In this problem, we're given a solid sphere rolling up a ramp, and we're asked to find the speed when it's rolled 3 meters up the ramp. So to start this problem, we need to find the height that it rolls up, which we can do as sine of 25 equals h over 3. We solve that, we get our height to be 1.267 meters, and so we know the height here is 1.267. Then we can use VCM equals square root 2gh over 1 plus c, where our height is here. And then our c, constant of inertia, is going to be 2/5 because it's a solid sphere. We plug that in and solve that out, and we get 4.213 meters a second, meaning that when it starts at this height and rolls down, it will have a speed of 4.213 meters a second. Therefore, if we take our initial speed and subtract it by the speed when it rolls down, then that means our final speed, or the speed we get here, should be our answer, 1.28 meters a second. However, this is not true, and that's because when you take the speed when it rolls down from here, you're assuming that all the PE becomes KE linear and KE rot. However, in this problem, we have a ball rolling up, and as it's rolling up at this height, it still has some kinetic energy. Therefore, not all of that energy was converted to either PE or KE. So we can't just use VCM to find the speed and subtract it if you can even subtract two speeds in the first place to find the difference. What we instead have to do is set up conservation of energy. So over here, we have KEI, the kinetic energy when it starts at this point, and that's going to equal potential energy plus its KE linear and KE raw at that point up here. And so what we're going to expand is 1 half mv squared plus 1 half iw squared equals mgh plus 1 half mv squared plus 1 half iw squared, and then this will be final VF and final angular speed. And we can also rewrite 1 half iw squared as 1 half iw squared equals 1 half m times the constant of inertia times r squared, and w squared is just v over r, so that means v over r all squared. The r squared is going to cancel out, so we're left with 1 half times the constant inertia mv squared. So we put that in for 1 half iw squared, and we are left with this 1 half mv squared plus 1 half mcv squared equals mgh plus 1 half mvf squared plus 1 half mcvf squared. All our m's are going to cancel out, and then we can plug in our numbers. We know the initial speed is 5.5 meters a second, so we have this 5.5 squared over 2 plus 2/5, 5 plus 5, or 5.5 squared all over 2 equals g times the height, which we found before, 1.267 meters, plus vf squared over 2 plus 2/5 times vf squared all over 2. Simplify this, and we have 8.758 equals 7/10 vf squared. Multiply both sides by 10 and divide by 7, then square root, and we get our answer, 3.53 meters a second. So basically, for this problem, you just want to remember that you have to set up conservation energy and not do illegal math like this.